Hi, I am yet coming again to you from a couch. It's crazy summer, but I'm just super excited to be hanging out with you in the fall. It's going to be awesome. This is section 1.3 and 1.4. The title is to write and solve algebraic models and error analysis. And I would wager that before we even met, this section is going to be more what you expected out of Algebra 2. So I know we kind of jumped in pretty hot with some word problems, but this will be more of your like step 1, do this, step 2, do this, sort of like algorithmic approach to solving for x. This lesson is also a nice bit of review of things you did a ton in geometry when you were doing linear pairs and setting up equations to solve for the missing value of an angle. I mean, this is all going to feel super familiar to you. Again, I'll be checking your notes somehow at some point. It's always something I kind of have to keep an eye on. So again, things that I highlight and things that I write should be written down. So right now at the top of your notebook paper, you would have that. Remember that you can also just print these notes or use the multitasking function in your iPad to take notes electronically on the same file. So those are your options. But if you're doing notebook paper, please make sure you have the title of the section at the top. Our goal for this lesson is to write and solve algebraic models, which we did a little bit of in the last section. And we're going to check our work and the work of some of our friends for errors. Our motivation is without a calculator. You're smart. So many of you are leaning on that calculator pretty heavy, and periodically our SAT scores show that our non-calculator stuff isn't so strong. So I usually chase down non-calculator items pretty heavily. But yeah, you don't need a calculator. You're super smart. You have a couple of warm-up questions, so I would like you to go ahead, take a second, pause the video, and go ahead and give those warm-up questions a try. Don't forget you're going to write the phrase warm-up. I should have highlighted that. And you'll copy number 1, 2, 3, 4, and 5. Just that phrase LCM there. Copy that highlighted stuff down, and you're going to go ahead and work those problems out. And we'll be back together in just a few moments. All right, let's go over it. Number 1, your answer there is 11b minus 12. Number 2, your answer is 8m plus 34. Number 3, I'll explain a little bit as well. You're going to buy 1 pair of jeans, so that's your 1n. And then if you're supposed to pay a sales tax rate of 5%, you have to add on what equates to the sales tax. So you see this expression right here, 5% is 0.05. And then if I want to treat that as a tax rate, I'm going to figure out what 5% of the price of my jeans is. Of in math class, just like difference in the last lesson, meant subtraction. Of in math class also means to multiply, if you can't remember that. So when I say of, I actually mean times. So 5% of n, we just write that as 0.05n. These are like terms, so I can add them up. So this becomes 1.05n. I know you've used this shortcut too. We live in Allegheny County. The sales tax is 7% here. So if you were ever in, I don't know, like Target buying a DVD or something like that where there's sales tax on that item, you know, you might go ahead and just grab your cell phone calculator real quick. If you have cash on you, you want to know if you have enough money to cover the cost of that item. You just do 1.07 times whatever that item is, and it tells you, the cost that'll come up at the cash register. So it's a real shortcut little trick that makes life a little bit easier. Or like if you're at a restaurant and you need to tip, let's say your waitress was really good and you want to tip 20%, you need to figure out what your total is. So you just take the price of your bill, multiply it by 1.2, and that'll tell you the overall price of your bill. So it's a real quick and easy way to figure out what a percent of an item is added on to the original cost of the item. Number 4, you're asked to evaluate that expression without a calculator. So I did part of it because I wanted to just jog your memory on just like a real quick little skill when we go to multiply a fraction by a number. You might recall, because I asked you to do it without a calculator, for this problem you do have to do the multiplication and divisions in the order that you see them. So we have to take care of this 3/4 of 16 first. So I'm going to go ahead and multiply 3/4 times 16. And to do that without a calculator, I'm going to use a cool trick called cross-canceling out my factors. So if I want to cross-cancel, you know, this 16 right now is like 16 over 1, right? And if I want to cross-cancel, I look diagonally across the fraction, and I'm like, okay, well, 4 and 16, what number do they have in common? 4 and 16 have 4 in common. So 4 goes into 4 one time, 4 goes into 16 4 times. So when I go to simplify this expression, it's going to be 9 minus basically just 3 times 4, and that's 12 divided by 2. And then out of the additions and subtractions and divisions and all that good stuff, I have to divide first here. So 12 divided by 2 is 6. And then 9 minus 6 is 3. So the answer to that problem is 3. Hopefully you were able to do that without a calculator. Periodically, I will have you put your calculators away so that you cannot use them. And I have ways of asking questions to make sure that you don't use your calculator. So just like on the SAT. If something says, you know, to put your calculator away, you're going to want to go ahead and just try your best. That's all I can ever ask of you, right? You try your best, we're good to go. And number 5, part A is 15, B is 24. C, if you're like, what are you doing? I was going to go ahead and run through your friend and mine, the factor tree. So factor trees, you might remember the prime factorization of 8. Which means, you know, you break it down into one prime number. So 2 is a prime number that goes into 8. 2 times 4 is what gives you 8. And then the prime factorization of 4 is 2. So the prime factorization of 8 is 2 times 2 times 2, also known as 2 to the 3rd power. And then I would do the prime factorization of 10. It's a little quicker. Prime factorization of 10. 2 is a prime number that goes into 10, and 5 is a prime number that goes into 10. So the prime factorization of 8 is 2 times 2 times 2, and then the prime factorization of 10 is 2 times 5. To find the least common multiple using factor trees, it's pretty easy. All I'm going to go ahead and do is copy down all of the factors from the item on the left. So if I look here, 8 is on the left. All of the factors that made 8 are right there. 2 times 2 times 2. So that's 2 times 2 times 2. So I copy those down. And then I use my eyeballs to compare what I have here with what I have on the right here in red. Now notice I have 3 2's here. And I have 1 2 here. Well, because I already have 3 2's, and I'm trying to identify what's called the least common multiple, not just a common multiple, I don't need this extra 2. I already took the 2 into account, say, with this 2 right here. So we'll knock this guy out. And then I don't have any 5, so this 5 has to come down. And then I multiply those things together, so that 5 came down there. 2 times 2 times 2 is 8, times 5 is 40. So the least common multiple of 8 and 10 is 40. Again, most of you are just going to think about what is the smallest number those things go into. So for instance, 3 and 5, the smallest number they both go into is 15. 4 and 24 is 24. But for 8 and 10, that would be 40. All right. Forgive me, I had to change scenery. It was getting a little rowdy in my house. But here in example 1, we're asked to solve a multi-step equation. So we're going to go ahead and solve this equation for x. And just if you're taking notes on notebook paper, you jot down example 1. And then you can jot down part A, and then that equation right there. So that equation says 3 times the quantity of 5x minus 8 equals negative 2 times the quantity of negative x plus 7 minus 12x. All right, step 1. So you're going to jot this down. You're going to simplify both sides of the equal sign. And when we say simplify in math class, that means to distribute and combine like terms. So So you'll jot down those things. And yeah, so let's do it. Step 1, on the left-hand side of that equal sign, I see that we're going to go ahead and distribute. So I'm going to distribute the 3 to the 5x, and that gives me 15x. And then I'm going to distribute the 3 to the negative 8, and that gives me negative 24. Then I'll bring down my equal sign. And then I want to also go ahead and simplify the right side of that equal sign. So I'm going to go ahead and distribute the negative 2 to the negative x. And negative times a negative is positive, so that'll be 2x. And then negative 2 times positive 7. The product of those two things is negative 14. And then I'll do minus 12x. Okay, so that was distributing. Now I need to go ahead and combine like terms. So when I look at that left side, that side in purple right there, the 15x and the 24 can't be described as like terms, quite simply because they don't have the exact same variable part. However, when I look on the right side of the equal sign, I do see some like terms. 2x, and I'm always going to treat this like it's a negative 12x. Those are like terms because they both have an x attached to them. They both have that exact same variable part, which was part of our vocabulary from the first section. So those are like terms. So what's in purple stays in purple. We got 15x minus 24 equals, and then 2x and negative 12x gives me negative 10x minus 14. Next thing I normally do is, and you'll go ahead and jot this down as well, I always move the variable term to one side. So I'm thinking most of you would look at your variable terms here. Sorry about that. It's supposed to be a pen, not a highlighter. You would go ahead and take a second to add this 10x to both sides. So we got to move all of our variables to one side. So those cancel each other out. And then when I go to balance the equation, so I'll bring down my equal sign, what's left over on this left-hand side here, I have the sum of 15x and 10x. 15x plus 10x is 25x. And minus 24 comes down. And then when I look at the right side of that equal sign, all I have left over is a negative 14. And then the last thing I'm going to do, once I have all my variables on one side, is I'm going to use a technique for solving we call SADMAP, and we'll do this lots of times this year. Step 3, we solve with SADMAP. This is often referred to as the inverse of the order of operations, or the order of operations backwards. Some books call it solving by undoing. I've heard it lots of different ways, but whenever we go to isolate a variable, in other words, get x by itself, we can't go forwards through the order of operations because there's not enough information there. We actually go backwards through the order of operations to isolate the x, to get the x by itself. So we look for, if you're just looking at the word, we're going to look for any subtraction or addition that we see in the problem. And I see that I'm trying to, in this particular expression on the left-hand side, I have a minus 24. So I have to undo minus 24. If I want to undo minus 24, I'm going to add 24 to both sides. So that gets rid of the subtraction, and I did it with addition, so that takes care of the S and the A. And I'll go ahead and now balance my equation. So on the left side, I have 25x. And then that's equal to the sum of negative 14 and 24. So that'll give me 10. And then I have to go ahead and look for any division or multiplication. And on the left side, I see that x right now, the guy I need to get by itself, is being multiplied by a factor of 25. So if I want to get rid of that multiplication, I now need to divide both sides by 25. The craziest phenomenon happened last year. I kid you not. I had kids, for whatever reason, dividing both sides by 10 there. Like they were trying to get rid of the 10. And I don't know where that came from, but that was like really strange. So again, if we want to isolate this x, we're trying to get the x by itself. So what do we have to get rid of? This 25, which means you're dividing both sides by the 25 to isolate the x. That was one of the stranger things I had encountered in a couple years, and I don't know where that came from. But I'm going to be proactive this year. Don't be that kid. So yeah, we divided both sides by 25 here. And then 10 over 25, both of those things have a common factor of 5. 5 goes into 10 twice. 5 goes into 25 5 times. So the answer to this is 2/5. Now, if I was teaching this lesson in front of students, which, hey, for decades I did, I would see little hands popping up in the air. Mrs. Lucas, can I just write it as a decimal? And for this problem, let me just go ahead and take care of this. You're going to hear me say it lots and lots of times. If there's no typewritten fraction in the problem, I did not go into an equation editor to type a fraction in this problem. Yes, you can write this as a decimal. It's fun. I get that. You like your decimals. You like your calculators. I know you. I know you. Fine. Write it as, your 0.4. Have at it. Now, things change, however, when I get into example 2. So hold that thought. Not example 2. Part B. Part B, I'm going to jot that down, and then I need you to jot down this equation. X plus 3/4 equals 5/8 minus x. You see that right there? That problem has fractions in it. We're going to use a special technique, and we're going to use this method. You don't have to write that down. Sorry, I grabbed the wrong thing. Okay, this. We're going to go ahead and use this method all year long. And I was actually just doing some research before this not too long ago. I thought this was kind of cute. The one math teacher called they call it the LCD method, but they called them bottom busters, which I thought was cute and kind of funny. Bottom busters. So the idea, because I'll be honest, I know quite a few of you are a little fraction phobic out there, and that's okay. If you don't like fractions, just get rid of them, to be honest. Like, I don't maybe like fractions as much as the next guy. Actually, I do like fractions. That would be a total lie. But, I think that for a lot of you who don't like them, if you were sitting next to a classmate watching this video, you'd be nodding at each other like, yeah, they stink, which is, fine. So get rid of them. Like, make them go away. So with that being said, this is the perfect type of problem where you would copy that problem as a fraction. You are not allowed to use decimals. So you would put your calculator aside, and I'd like you to go ahead and practice this technique. I kid you not, we use it all year, so we might as well get to it. And it's nice because if you don't like fractions, so that's what we're going to do. I'm going to go ahead and copy this problem. Give me a little bit of space. So you copied this problem too, I think. So if you don't like fractions, let's go ahead and practice getting rid of them. The idea is to look at the bottoms. We're going to use a bottom buster, also known as an LCD. And that's why I had you do LCDs in the warm-up. Think about the LCD between 4 and 8. And you want to think about all of the denominators in the problem. And think about the LCD of all of the denominators in the problem. So this problem only has 2 denominators, 4 and 8. And when I think about the LCD of 4 and 8, in other words, and this was a warm-up problem, the smallest number both of those numbers go into is 8. So I'm actually going to put this 8 out in front, and I'm going to go ahead and distribute the 8 into both sides of this equal sign. So I'll distribute the 8 to the left side of the equal sign, and I'm going to distribute the 8 to the right side of the equal sign. That's my multiplication property of equality. What you do to one side, you got to do to the other. So 8 times x gives me 8x. And then remember how I had you multiply fractions in the warm-up too? If we do 3/4 of 8, I'm going to use that cross-canceling technique. 4 goes into 4 one time. 4 goes into 8 twice. 2 times 3 is 6. So that's that left side simplified. And then I got to distribute 8 to 5/8. Again, 8 and 8 have a common factor. 8 goes into 8 one time. 8 goes into 8 one time. 1 times 5 is 5. But it's not like that 8 really went away because I still have to distribute it to, I just don't want that to be misleading. I still have to distribute that 8 to the x as well. So this will be minus 8x. So yeah, I distributed the, 5/8 of 8 is just 5, and then I have my minus 8x there too. So now we have a problem, we've simplified both sides of the equal sign. We got rid of our fraction, so we busted the bottom by using our friend the LCD. It's amazing. So if you multiply both sides by the LCD, the fractions go away. And I'll demonstrate this a couple more times for you. But yeah, we're going to move all the variables to one side now. So I'm going to add 8x to both sides. And I'm just doing the steps that you already jotted down above. So 8x and 8x is 16x plus 6. And that equals 5. And now I have to SAD map. So I'm going to undo any subtraction or addition that I see in the problem. Here I just need to subtract 6 from both sides. And then I need to undo any multiplication or division that I see in the problem. So I'm going to divide both sides by 16. And the answer to this problem is negative 1/16. Just a little reminder, you can actually check these particular problems just by plugging the number back into the original equation. And the idea would be that you get the same thing on the left side and the right side. But negative 1/16 is the answer. So you're probably asking that question, Mrs. Lucas, can I write that as a decimal? Okay, for this problem, the answer to that would be no. I would not give a decimal answer credit on this problem. I actually do need to assess your understanding of the lessons that I teach you, and the purpose behind this example was to use the LCD method to get rid of fractions that appear in a problem. So I need to make sure you can do that. So you have to show all of your work and your answer in fraction form. In general, when you see a problem that has a typewritten fraction in the problem, like we did here, typewritten fractions, those aren't easy for me to make. So I want you to go ahead and make sure you show all of your work and your answer in fraction form. Make sure your answers are also in fractions. So hopefully that helps you get rid of fractions in a problem. So now we get to the lesson where we get to apply our algebraic understanding. So instead of doing step 1, do this, step 2, do this, we kind of get to apply our thinking and, just kind of see how this stuff plays out in the real world. So we have our word problem. I'm going to do a couple. This example here says it takes you 8 minutes to wash a car, and it takes a friend 6 minutes to wash a car. How long does it take the two of you to wash 7 cars if you work together? So step 1, we always read it and read it again. Step 2, we're going to make a list of the things that we know and a list of the things that we don't. And what's interesting in this problem is the information that they're giving us to pull from is actually a rate. The rate at which you wash a car. So you wash a car at a rate of 1 car every 8 minutes. So if you had 8 minutes, you'd wash 1 car. If you had 16 minutes, you'd wash 2 cars. If you had 24 minutes, you'd be washing 3 cars. So that's your rate at which you wash a car. And then the other piece of information they give you, they say it takes a friend 6 minutes to wash a car. So we have another rate, right? So friend washes car. Sorry, I forgot to back up for a second. So in your notes, for organizational purposes, you want to make sure you have example 2 written down. And then everything that I write down on the slide, you write down on the slide. So right now, you have you're coming up with 2 rates. This is our given information, or the information that we know. So you wash a car, 1 car every 8 minutes, and then your friend washes a car. They wash 1 car every 6 minutes. So your friend's a little quicker than you. Time to step up your game. Just kidding. And then it asks, how long does it take the 2 of you to wash 7 cars if you actually get to work together? So I'm still in the process of listing out all of the things that I know and all of the things that I don't. And the next sentence asks asks me how long does it take the two of you to wash the cars. So I said, you know, if you don't know what you don't know, look at the question. It's asking us how long. Well, what we don't know, then, if I'm making my list of the things that I know and the things that I don't know the time it takes for us, we'll say me and my friend, to wash cars, right? And I guess specifically it's 7 cars, huh? So I'm just going to call that variable t for time. We're going to talk in chapter 2 about things that are dependent variables and independent variables. And one of our most common independent variables or control variables is time. Time controls a lot of things. How much money's in our bank account, our paycheck at the end of the week, how much bacteria is in a petri dish. So t is a variable we use quite a bit, and it's a control variable in a problem. So you're going to use the variable t quite a bit in this class. So the time it takes for us to wash cars is t. We don't know what that is. We do know the total number of cars, though. Our total number of cars is 7. So I'm going to go ahead and just slide that in right there. The time it takes us to wash 7 cars. So that was the first thing we did. We even declared our variable. You know, it's time in minutes. Okay, now we're going to go ahead and write our formula or our verbal model. And I know that, you know, I'm basically combining 2 things together because my friend gets to wash some cars and I'm going to wash some cars, but together we want to wash a total of 7 cars. So that's kind of me building my verbal model. I have the, we'll say, I'm going to use a different color. So we're going to say the number of cars I wash, number of cars, me, plus the number of cars, and you can do it however you want, really, my friend washes, friend, will give us our total number of cars. And the total number of cars is kind of nice because they gave us that little gem in the problem. So total number of cars. And in this case, total number of cars, they told us that. It says we are going to wash 7 cars. And if you need to rewind the video, I'm going to reference something I talked about just a few seconds ago. I talked about how the given information wasn't just the 8 minutes. It was actually a rate. They were telling us you wash 1 car every 8 minutes. So that if I had 16 minutes, I'd be washing 2 cars. If I had 24 minutes, I'd be washing, 3 cars. If I had 32 minutes, I'd be washing 4 cars. So what's the expression then for the number of cars I wash? Well, I'm taking 1/8 and I'm multiplying it by the number of minutes I have. Or I'm taking my number of minutes and dividing it by 8. However you want to write it. You can either do t over 8 or 1/8 times t. Because I'm going to use that bottom buster, that LCD method that we just talked about, I'm just going to write it as 1/8 t. Okay. I'll bring down my plus sign. And then my friend's a little faster. My friend washes 1 car every 6 minutes. So if my friend had 6 minutes, they'd get 1 car done. If they had 12 minutes, they'd get 2 cars done. If they had 18 minutes, they'd have 3 cars done. So the expression that we could use to model the number of cars my friend would wash would be 1/6 times t. So that's our equation that we get to solve. 1/8 t plus 1/6 t equals 7. So I'm going to go ahead and bring that equation down, give them some room to work it out a little bit because I want to use the bottom busters. So I'm going to go ahead and do 1/8 t plus 1/6 t equals 7. And you always notice when I write my t, it's got a little hook at the bottom, but the plus sign is just no hook. So if you're wondering why I'm doing that with my t, it's so that it doesn't look like a plus sign. All right, so we have 1/8 t plus 1/6 t equals 7. You could, if you wanted to, combine like terms on the left side, but I know a lot of you don't like fractions, so we're going to go ahead and get rid of them. And I'm going to get rid of them by using that bottom buster technique we talked about in the last example, that LCD method. So right now I just have to think, what is the common denominator between 6 and 8? In other words, the smallest number they go into. They both go into 24. So So I'm going to distribute the 24 in. 1/8 times 24, or 24 divided by 8, is 3. So I have 3t as my first variable part there. And then I'll distribute the 24 to the 1/6 t. And we could even use that cross-canceling method if you like 6 goes into 6 one time, and then 6 goes into 24 4 times, so that'll be 4t. And then what I do to one side of an equal sign, I also have to do to the other. So I have to do 24 times 7, which is 168. And then I would go ahead and combine like terms. So I have 3t and 4t, that's 7t, equals 168. And then I have to undo that multiplication, so I would be dividing both sides by 7. So I'll pop up here for a second. We got 7t equals 168, and I got to get that t by itself. So I'm dividing both sides by 7. T equals 24. And, you don't want to leave me any naked numbers. If we were in my classroom, you could see the poster of it, No naked numbers. We need units. So we have 24 minutes. Is the time it should take my friend and I to wash 7 cars. So we always write that in a sentence, and you can go ahead and write your summary sentence now. I'll now go ahead and do that with you. So it takes us 24 minutes to wash 7 cars. And that's your answer there. Okay, the next thing I wanted to talk about was, this question here. And, people will go through great lengths to support why something's right? Like if you have an argument, you really try to support your side of your argument with some reasoning. So we do the same thing. We practice that in math class too. It says, how do you know your answer is accurate? How do you know it's right? Well, you could very easily take your 24 minutes and you could plug it into the equation and make sure that it checks out. So if we did, 1/8 of 24 plus 1/6 of 24, we get 3 plus 4, and that's 7. So that definitely works. Another way is that it just seems logical. I didn't get a negative number, right? It's not like I went back in time. I didn't get something that was like a million, so big that my friend and I would be, grandma and grandpaps by the time we finished. This answer just seems to make sense. So sometimes it's just as simple as that. Like, does the answer look right? And I actually think it does. I also like when answers in this class come out as like a nice whole number. That's like a huge giveaway. If you get really weird decimals or things like that, I still, while we're learning new skills, try to keep the answers coming up pretty tidy. Now, because you're honors, every once in a while you do get some messier numbers because, well, hey, the honors kids have to deal with the messy stuff too. But, I wanted to let you know that for the most part, when you get a nice, neat number like that, usually you did it correctly. So that should bring you some comfort too. Okay, our last couple of examples really just have us solving for a variable in an expression. And this is a super handy way of dealing with things when the numbers are so messy that when you plug in those big messy numbers, errors come out. So sometimes plugging in the numbers is just something you should save until the very end to increase the degree of accuracy of your response. So I just want to show you this cool trick to help you make your answers super accurate if you need them to be. And the technique we're going to practice is solving for a variable in an equation. So in this first little part right here, you're probably wondering what you should highlight. So you want to have example 3. And what we're going to do is we're going to solve in part A here, P equals 2L plus 2W for W. So that's what we're going to go ahead and take some time to do. So you go ahead and jot that down. And hopefully as you're jotting it down, this formula hopefully strikes you as something you've seen tons of times before. It is the perimeter for a rectangle. P is perimeter, and that can always be found by finding the sum of 2 lengths and 2 widths. So let's go ahead and take a second and use our SADMAP to solve this equation for, whoops, that's the highlighter, solve this equation for W. So we have P equals 2L plus 2W. Hopefully you jotted that down. And I need to get this W by itself. So again, the technique I'm using is SADMAP. So I want to undo any subtraction or addition that I see in the problem. And when I look at this, what I see here is that this 2L is being added on to the variable part that has the W in it, the 2W. So I need to get rid of this 2L first. So I'm going to do that by subtracting 2L from both sides. And then I'm going to balance my equation. So on the left side of the equal sign right now, I have P minus 2L. Those are not like terms, so I cannot combine them. So I just bring them down. P minus 2L. I also keep equal sign under equal sign, and then I simplify the right side of the equal sign. Well, those two things undid each other, and so now what I have on the right-hand side is 2W. And notice that that W is still not quite yet by itself. I need to get that W all alone. That 2 is in the way. Well, to get rid of that 2, I notice the operator that's in between the 2 and the W, it's a product. So if I want to undo a product, the opposite of multiplication is division, which means I need to divide both sides, the whole side, by 2. So what I have now on the left side is P minus 2L all over 2 equals, and then 2 over 2 is 1, so that's equal to W. And that's just one way you could write that answer. Some students are going to want to write it maybe in a slightly different way. They're going to take this 2 and actually maybe even divide a little bit. Remember, you got to take the 2 into all of the pieces. So you might have P over 2 minus 2L over 2, which would just simplify to be L. And I'll be honest with you, either of those things is correct. It's whichever one you prefer. So now what we're going to go ahead and do is finish the second part of the problem. So the second part of the problem that you're going to go ahead and jot down is I have to go ahead and find the width of a rectangle that has a length of 12 meters. So they're going to say the length is 12 meters and the perimeter is 41 meters. So that's what I'm going to go ahead and do right now. So what they're saying here is I have to now one of these days, I can get better at that. Sorry about that. Okay, so we have to now let me see here, the length equal 12, and I have to let P equal 41. So I'm going to copy down my expression. And I think I like this easier looking one we grabbed. I like this P over 2 minus L equals W. And where I see the L, I'm going to put in a 12. And where I see the P, I'm going to go ahead and put in a 41. So that P turns into a blank. And P in this problem, I'm going to go ahead and substitute the 41 in. Minus L, which we know is going to be 12. And then that is equal to W. And then I got to do my order of operations. So I see division and subtraction on that left-hand side. So I would go ahead and just take a few minutes to divide first. So 41 cut in half would just be 20 and a half. Minus 12 equals 8 and a half. So my W is 8.5. So we could say W, or our width, is 8.5 meters. Now it's time for you to practice. Let's see if you can do it. Go ahead, take a second, pause our video, and let's see if you can, in part B, solve for Y. And then tell me what Y is when X is negative 5. And then in part C, take a second, solve for Y, and then find the value of Y when X is negative 3. All right, let's talk it over and see how you did. In the first one, remember you're going to have 2 answers for each of these. Your first answer for part B there is Y equals 9/4 X minus 7/4. And then you took your negative 5 and plugged it in. Just remember that whenever you multiply fractions, you're going to go ahead and just kind of multiply straight across. So what you're going to see is that I took 9/4 times negative 5, And essentially, I treated this -5 like it was over a 1. So 9 times -5 gave me the -45, and then the 4 times this 1 on the bottom. 4 times 1 was 4. So I got -45 over 4 minus 7 over 4. And, you know, when we subtract fractions, you just combine the numerators when they have the same denominator. So I just did -45 minus 7, which is -52, and the 4 comes along for the ride. And then if I take -52 and divide it 4 ways, I just get -13. It's like there's 13 cards in each suit in a standard 52 card deck. And then in part C, we got 2x plus xy equals 6. So my final answer when I got the y all by itself was y equals -2 plus the quotient of 6 over x. And then I went ahead and I let my x equal -3. So where the x was, I put the -3 in. I did my order of operations, so I had to divide 6 by -3 first, and I got -2. And then the sum of -2 and -2 is -4. So hopefully you got those. If not, holler at me. All right, let's go ahead and apply it. We have one more word problem and then a couple of independent practices, and you're done with this section. So your day of math is coming to an end. So to apply it, we have a college bookstore will oftentimes offer to buy your books back from you when you are done with them at the end of a semester. One bookstore will buy psychology textbooks for $5 if they're in new condition, but for $3 if they're in fair condition, so just not as new. In part I here, we're asked to write an equation that represents the amount that bookstore will return to students who opt to sell back their psychology textbooks. So we could take a moment to just kind of highlight some things that we know. So for instance, a book is $5 if it's in new condition. So if I return one new book, I'd get $5. 2 new books, I'd get $10. 3 new books, I'd get $15. So if I want to just let n be, I'm going to call this guy here n, new condition, I can say that the expression for the return I would get on the new books would be 5 times n. And again, for your notes, for your notebook purposes, you want to have the let's apply it. And this is technically part D, and we're working on part I of part D. And right now you have a 5n under there. Also, you have something about it being $5 if it's in new condition. And then we got to talk about if it's in fair condition. So if it's $3 in fair condition. So that means that if I return one fair condition book, I'd get $3. 2 would be $6. 3 would be $9. So this would be 3, we'll call it F for fair condition. So that was F, was my fair condition book. And then what I'm trying to figure out is how much money I get back. And that, my friends, is something we call the return. Oops, meant to use a highlighter there. So that is a return. So we're trying to figure out what the return will be, and I'm going to go ahead and call that R. R is my return. That is the refund or the money I will get back. So that's an equation that represents the amount the bookstore will return to me, R. I guess I decided to use a big R there, for students who opt to sell back their psychology textbooks. You might be wondering why I had to introduce a new variable, because in the last section I didn't have to do that. Well, what you're seeing right now is that I don't know the total number of books I'm taking back. It's not like I'm returning 15 total books, so n of them were new, which means 15 minus n of them were fair. There's no mention of how many total books there are. So I actually had to introduce a brand new variable here. So if you're wondering why it doesn't look exactly like it did in the last section, that's why. I don't know the total number of books. All right, on to part 2. It now says, hey, solve this equation. So I'm going to solve my equation from the previous step. I'm going to solve that equation for the number representing the new books. So let's go ahead and do that. So I'm going to take my equation here, which was 5n plus 3f equals my R, and they're asking me to solve for the new books. So I'm going to get that n by itself, which means my first step is to undo the addition that I see by subtracting 3f from both sides. I'll go ahead and come up here and balance that equation. So I have 5n left on the left, and I have negative 3f plus my r on the right-hand side. And then I'll go ahead and divide both sides by 5. And I divided the whole side by 5. So what I have here is now an equation for n. I now know that the answer to this part of the problem is n equals negative 3/5 f plus r over 5. And then in part 3 here, it says as a fundraiser, so let's highlight our 3 there. As a fundraiser, a group of psych students wish to sell their textbooks back and give their money to a local charity. It's very altruistic. They hope to raise $1,300, a total of $1,300. So their return that they're hoping to get is going to go ahead and be $1,300. So they're telling us what R is. So our return, or our refund, that was our R variable, is $1,300. And then it says how many books in new condition, so we don't know how many are in new condition. How many books in new condition must be returned if the number of texts returned in fair condition is 100. So they're saying, hey, let F equal 100. So let's go ahead and grab our equation from the previous step. That's the great thing about algebra. You're always just kind of recycling what you did in the previous part of the problem to get to the next piece. It's kind of reassuring. You always got your first thing kind of done for you because you did the work beforehand. So I don't know what n is. I do know what f is. That, my friends, is supposed to be 100 books in fair condition. So I'll grab that. And then my return that I was hoping for was $1,300. And then I'll divide that by 5. So number crunch that a little bit. Basically taking 1,000 divided by 5. Looks like we're going to get 200 new books. Must be returned. That's a little bit of algebra helping you solve a problem. All right, we're almost done. Alrighty, folks, you're almost done. You got 3 left. So these will be your conclusion independent practice problems. Hopefully, you're getting a little bit accustomed to them. So you could just highlight this part of your notes as conclusion independent practice. And all I want you to do is solve. So you're going to go ahead and solve part A. It's 1/4 R plus 1/6 R equals 5. Part B is 5/3 Q minus 9 equals 1. And part C is 56 equals 4 times the quantity of 4 plus 2z. Remember, typewritten fractions in the problem. See these dudes right here? This guy and this guy. Typewritten fractions in the problem means all your work and your answer is in fraction form. I want you to practice those fractions because if you don't like them, you got to figure out how to get rid of them, right? So you're going to go ahead and give those some good practice. Pause the video, and then I'll have them all worked out for you when you hit play again. All right, take a second and check them. For part A, I distributed the 12 in because 12 is the smallest number that 4 and 6 go into. That's how I got the 3R plus the 2R. And then 5 times 12 is 60 on that right-hand side. Combine your like terms. I got 5R equals 60. Divide both sides by 5, and you get R equals 12. For part B, I got Q equals 6. Pretty straightforward. I just multiplied both sides by 3 to get rid of that, 3, that fraction that has the 3 in the denominator there. Part C, that when we're responsible for simplifying both sides of an equal sign before we go ahead through SADMAP. And when I say simplify, I mean distribute and combine like terms. So I did distribute on that right side first to get 16 plus 8z. Fun fact, you could have just jumped right into just dividing both sides by 4 first to get rid of that 4 also. So that's a cool trick you could have also done. And then your final answer there is z equals 5. Hey, this was a long lesson. I'm super proud of you for hanging in there. You watched the video. Watching the video and taking notes and doing your independent practice conclusion was a lesson. And it was your homework for today. So you are done and you're killing it. So I'm super proud of you. We'll do a little practice in our next lesson.